Now we are going to start our discussion on programmed IO, which is one of the most important thing in this chapter where application level based questions can come. So here we have to understand that there are three techniques which are possible for IO operation. To do an IO operation, there are basically three techniques which are there. That is programmed IO, interpret driven IO and DMA. So each one differs in how much the CPU is involved. Like how much the CPU is involved in each of this operation is different. If you consider the programmed IO, with programmed IO data are exchanged between the processor and the IO module. The CPU directly handles all the communication with the IO module. It's the one doing all the asking, checking and transferring. So that means here in the programmed IO, you have to understand that in programmed IO, the CPU is completely involved. So the CPU, the data are exchanged between the processor and the IO module. Here means CPU is directly handles. Here CPU is always involved. CPU is handling all the communication with the IO module. Like it will check, it will ask the IO module, like asking the IO module, checking the state and transferring. All is done by the CPU itself. Okay, so CPU is handling all the communication with the IO module. So the processor execute a program that gives direct control of the IO operation, including sensing device status, sending a read or write command, and transferring the data. So this here what happened is that the processor would execute a program that gives it direct control of the, this processor would have a program. That program is giving the processor the control of this IO operation. So that means in programmed IO, the CPU is doing everything. It will first ask the device status, then it will send the read or write command whatever it needs, and also transferring of data. All is done by the CPU itself. Think of CPU like acting like a person who personally walks to the printer, check if that printer is ready, and hands it a paper and waits, doing every step manually through a program instruction. So the processor would do is that processor execute a program, and that program is giving it the control over this IO operation. So it will do the checking of the device status and sending the read or write command and transferring the data. That means here the analogy, if you see CPU, let's imagine the CPU like a person. It will go to the printer itself, it will ask, it will see if the printer is ready, it will put the paper inside the printer, and it will wait. Like everything is done by the CPU, like manually we can say, through this program, because this program which the CPU is executing would give the CPU or the processor, CPU or processor, right, it will give its direct control to this IO operation, right? So that means here the CPU itself would check the device status and send the read or write command and transfer the data. All is done by this processor itself. So when a processor issue a command to the IO module, it must wait until the IO operation is completed. So after telling the IO module to do something, the CPU would sit here and keep checking repeatedly, are you done? It will ask the IO module, like the CPU is giving the CPU, or we can say processor would give a command to the IO module, and the IO operation has to be completed. So what happened is that the processor would sit there and wait for this IO operation to get completed. It will sit down and it will ask the IO module if it is done. If it is done repeatedly, this is repeatedly happening. So this is called as the loop. This kind of loop which is repeatedly asking is basically called as this pooling. So there is a word called as pooling, and this process repeatedly asking is basically known as the pooling or busy waiting. You can see here at the end, right? So when a processor gives a command to the IO module, and the processor has to wait until this IO operation has been completed. So it will keep on asking the IO module if it has done the work, if it has done the work. So it's a loop. So what happened, this is known as pooling or busy waiting. Okay, so you have to understand that our IO operations, there are basically three types: programmed IO, interpret IO and DMA. In program IO, CPU is having the direct control. CPU is doing the communication with the IO module directly. That is, it will be asking, it will be checking, it will be transferring. So this processor would execute a program that would give this CPU the direct control over this IO operation. So that means it will check the device status, it will give the read or write command, and it will wait for this, it will transfer the data, and it will keep on waiting for the IO operation to complete. So it will give a command to the IO module, and it must wait until this IO operation has been completed, this, and it will see if whether you have done, it will be repeatedly asking that. So that is called as, like, in a loop, this is called as pooling or busy waiting. So that you have to understand the word pooling or busy waiting. So the processor, we know processor is faster than the IO module. So this is a wasteful for the processor time, because we know CPUs are very faster than most of the IO device. So IO operation would happen very slowly. So CPU has to wait a lot of time for the slow device to finish its thing, right? So this would waste the processor's time. Okay, so that is happening in programmed IO. Wasting of processor's time is happening. But now let us consider a minute, guys. Now let us consider what is happening in interpret driven IO. Now this is kind of like a solution, kind of the problem which is faced here, that is the waiting of the CPU until the slow IO operation has been finished. That problem is resolved in this interpret driven IO. That is, in interpret driven IO, the processor would issues an IO command, and it will continue to execute other instruction. And when it is finished, when the IO operation is finished and it is interpreted, our CPU would be interpreted by the IO module when it has been finished its work. So in interpret driven IO, what is happening is that the CPU would give command. First thing is the CPU would give command to whom? It will give commands to the IO module. Then it will go and execute other functions, right? It will execute other. Then the IO module, after finishing the operation, would give what? Interrupt to whom? The CPU. So it will stop its current executed work, and then it will do the work which was done using this IO operation. So here what happened, the CPU is not waiting for the completion, right? CPU is not sitting on waiting for the completion. So this is the advantage here. CPU is not waiting for the completion, right? So here the thing that you have to understand is that with programmed and interpret IO, the processor is responsible for extracting the data from the main memory for the output and storing the data in the main memory for the input. That means whether waiting or not, in both the method what is happening, the CPU must personally move the data between the main memory and IO module, and the CPU is always the data transfer loop. In both the cases, the thing is that programmed and interpret IO, in both the cases, CPU is responsible for taking the data from the main memory for the output. And also, if you want to store some data in the main memory for input also, it is both done by the CPU itself. Whether waiting or not, in both the cases, what happens, CPU has to move the data between the main memory and the IO module. That is, data transfer loop is done by the CPU itself. So for that, there is an alternative method, that is direct memory access, that is DMA. In this mode, what happened is that the IO module and main memory would exchange the data without processor's involvement. We will see how it is done and all detailing. But right now we have to know just a small idea about what do we mean by interpret driven IO. We have understood. In DMA, what happened is that the main memory and IO module would be having this exchange of data would happen, and there is no processor involvement, because in programmed and interpret, the processor is involved in the exchanging of data between the main memory and the IO module. But what happened is that here the exchange of data is not involved by the processor, and here IO module and the main memory can exchange the data directly without the involvement of the processor. Just understand just the basic difference here. Now let's understand programmed IO in detail. That is what we are going to do, understanding of the programmed IO. Fine. So if you see, when the processor encounters an instruction which is having IO in it, which is related to IO, It executes that instruction how? By issuing a command to the appropriate IO module. So when the processor is doing some or trying to execute an instruction or a program which is related to IO, it would execute one command. It executes that instruction. How it will execute that instruction? By issuing a command to the IO module. So anytime when the program has an IO instruction, like if it have to read from the keyboard something, the CPU would send a command directly to the IO module. So that is the first step. So whenever the first step is what? Whenever a processor is encountering an instruction that is involving or it is related to IO module, it executes that instruction how? By sending a command to the appropriate IO module for doing that. Okay. So with programmed IO, what happened is that the IO module will perform the requested action and then set appropriate bits in the IO status register. So we have in IO module status register. So when a command is given by the whom? The command is given by whom? The command is given by the CPU. The IO module will perform that action and then it will put the appropriate bits in the IO status register. That means when IO module finishes its work, it simply updates its status register. That is what it do. So IO module takes no further action to alert the processor. It does not interpret and all. There is no interpret and all. It's just put that status register. In the status register, it will just keep the status. It will not interpret the processor and all. So the module does nothing. It doesn't notify the CPU. Just what it do is that it basically keep that bits in the appropriate bits in the IO data register. So it is the responsibility of this processor to periodically check the status of this IO module until it's find the operation is completed. Now what happened is that until the process is completed, the processor has to periodically check this IO status, that IO module, to find what would be the status. Right, the processor would periodically has to now check what the IO module, status of the IO module until it finds the operation. So until the status IO status register is like completed, then only it can take the data which is there. So there is pooling happening here, right? This is the main thing that is happening here. That is, first the processor would encounter an instruction which has what? An IO in it. So it will execute, it has to execute an instruction. It will send that command to the IO module. IO module would execute that command, and when it is finished executing this, it will set the appropriate bits in our status register. But IO module just do that only. It will not interpret and or the processor that, or it does not alert the processor. So it is a responsibility of this processor to check this IO module periodically and see if the operation has been completed or not. Right. Until it finds this operation completed, have to check the status of the IO module periodically. Now there is control, test, read and write. Control is used to activate a peripheral and tell it what to do. Test is used to check the status. Is the device powered on? Is it available? That is why test is used. There's an error. Okay, this is what the CPU checks during pooling. Now read causes the IO module to fetch one item of data from the peripheral devices and hold it in the data register. Write, the reverse, cause the IO module to take the data item from the database and send it to the peripheral devices. So here you have to understand the four important IO commands. Control. This control is basically used, we know control is used to activate the peripheral devices, and this control signal will tell the peripheral devices what to do. Okay, each device tab has its own unique control instruction tailored to its hardware. So each of these devices have its own control signals. Okay, so control is basically used to tell the device what to do. Now there is test. This test is what the CPU is periodically checking. It's actually checking the status. Is the device is powered on? Is this device is available? Has this last operation has been completed? If an error occurs, this is what the CPU checking periodically is test. So telling the device what to do is control. What the CPU checking periodically is test. Read means what? Whatever the IO module would, whatever the peripheral device has, that data has to be fetched. One item of data from the peripheral devices and hold it in the data register. CPU then picks this through the data bus. Write means what? The IO module has to take a data item, that is a byte or a word, from the data bus, and it has to put to the peripheral device. So read means you have to read it from the peripheral device. So that data you will take, IO module will take it from the peripheral device and it stores it in the data register, and the CPU then picks this data using the data bus. Write means what? From the data bus, the IO module would take the data and then it will send it to the peripheral devices, the write. This is a basic for IO command. So if you see the programmed IO, in the program IO, CPU encounters something which has IO. So it will send the command to the IO module. IO module, what it will do? It will work. It is working on that instruction. So the CPU is doing pooling, busy waiting. So always checking the status of the IO module. When the status is done, the status bits, the sees what? The status bits are given to the CPU. Now the status bits are given to the CPU means it sees the done bit. So IO module sets a done bit in the status register. CPU on its next port reads the bit and sees that operation is completed. So CPU transfer, when the operation is completed, the CPU transfers the data from the IO module's data register. CPU now can transfer the data from the IO module's data register into the memory. So from the CPU, the data transfer can occur, or sometimes from the memory, I have to take it to the device. Only then can CPU perform the next. So, or from the device, from the memory to the device for the output. That two direction it is happening. Either the CPU can transfer the data from the IO module's data register, the data is stored. From there, it will take the data and put it in the memory, or from the memory, it can give to the data register and then to the external device, like that. That is read or write thing is happening. Reading the data from the peripheral device, writing to the peripheral device. There are two things that is happening. So CPU first would execute a program which is containing an instruction that is containing related to IO. Then if it has to execute that IO, it will send a command to the IO module. IO module would actually works on this command, and after it has been finished executing, then only it will set its status done. Okay, until then the CPU has to wait and check the status at each of this. Periodically it has to check the status. When it sees done, only the data transfer would take place. Understood? So in programmed IO there is no interpret, but IO and DMA there is interpret. Understood? Now this is about the programmed IO in detail. Now these are actually the part of interpret driven, which we don't want to see, interpret and DMA. Now we have to see this. That is, this is a diagram of programmed IO. So right now we will learn this diagram of this programmed IO. So here, if you see this diagram, first thing, the programmed IO, CPU does everything itself and keeps checking whether the IO device is ready or not. So first of all, the CPU sends a read command to the IO module. Here if you see, issue a read command to the IO module. CPU is sending a read command to the IO module. That is what is first happening. Okay. CPU continuously read the status register of the IO device. Now, read status of the IO module means from the IO module there is status register that is given to the CPU. Means the CPU is always checking the status register value is always given to the CPU, because CPU is checking the status register. So that means read the status of the IO module and it will check the status. If it is not ready, it has to will again check the status, like that. Now sometimes an error condition can also occur. If it is ready, see, if it is not ready, keeps checking. If the CPU reads, if it is ready, CPU reads one word, CPU reads a word from, it is actually reading. So it means the CPU, if the device is ready means from the IO module, the CPU would read word from the IO module. And then the CPU will write, we are reading, that means whatever data we read from the IO, we have to give it to the CPU, and the CPU would give that word to the memory. Then if it is done, we will check. Okay. Now, not done means we have to repeat again the process. Otherwise, we will go to the next instruction. Done means. Fine. So here what happens in programmed IO means, in program IO, first what happens, if a read command is given by the CPU to the IO module. IO module has to always the read status of the IO module would be always, that is the status of the IO module, if it is ready or not to read the data from the external device, it will check the status that is happening from IO to CPU, right? If it is ready, then only it will read that word from the IO module, and then only the CPU can give it to the memory, write the word to the memory. Then we will see if it's done or not. So when it's taking status, if this read status of the IO module says not ready, then it has to go and check it again, right? That is what is happening here, and this is how the programmed IO is basically working. This is busy waiting and pooling condition. Okay, so here this is interrupt driven and direct memory access diagram that we will be learning when we are depthly talking about interrupt driven and direct memory access. Okay, in this video we have only discussed programmed IO in detail and the steps here. The step is that I will just repeat the steps again. In programmed IO, what is happening in programmed IO, when the CPU is executing an instruction which includes which is related to an IO, it will send in order to execute that instruction, it will send what? It will send a command to the IO module. So IO module would have to do that operation which is there here, and after completing, it will set this status, that is what here, status registers value. So but after setting the bits, appropriate bits in the status register, in the IO input status register, it is not going to alert the processor and all. It does not interpret the processor. Processor itself has to check the status register every time, the status of the IO module every time, to see if the operation has been completed or not. Then we have learned the different 4 IO commands. There is control, test, read and write. Control is what? Control is nothing but it tells the device what to do. Test is what? The test is what is happening is that this is what the CPU is checking, the things that the CPU checks during the pooling loop. Now read is the, write is the reading the data from the peripheral device. Write means from the CPU, from the database we are writing the data to the peripheral device. Now this is what is happening. Command is given to the IO module. IO module would be working on that command, and when it is done, the status would be given to the CPU. The status bit would be given to the CPU. It will see done. That means the CPU can now read, data transfer can take place, right? Can either write to the memory or read from the memory. Two things can be there, happen there. So 2-direction diagram can be there. Then we learned this diagram, and this diagram, that is this diagram is important, and you have to draw it in the exams also. That is, so therefore you have to learn this diagram. Thank you.